Okay. So we might have a few more interruptions because I usually lock out the meeting at about 15 after. That's like 10 minutes out. But I'm not probably not gonna lock it out. But I hope everyone had a good weekend. I'm trying to think. We don't have a lot that we have to do. So in this section, we don't have that many slides. So like today, I only want to get through about 8 slides, right? So with the remaining time, actually, one of my students asked a question earlier. I might just go ahead and include it in today's presentation. But he was I guess he had already started section 2.1. So we'll throw. I'll probably throw that in there because it was a great compliment to the time. And but if anyone has any specific questions, we can answer it towards the end of class. Kind of give me the start of class to kind of go through the slides I need to. But feel free to make use of the chat or unmute yourself. Like this. I'm not gonna hop over here. This is. I'm gonna hop back here. Hopefully that should behave properly. But yeah, feel free to type in the chat or unmute yourself if you have a question or inquiry about something. I think we got another visitor. Okay, let's do like this. I think that works. Okay. I think we're back. Let me just do a quick glance to make sure it's working properly. That's good. Okay, I'm not gonna worry about it. Let's see. So exam 2 over the second half of chapter 1 was available starting from last Wednesday up until this past Saturday. You can actually work on it this past Saturday, but after Saturday it's like a 10% late penalty. For our midterm grades, I think I submitted midterms before the exam. I think we took time in class for me to have a quick one-on-one with each student last time. But the midterm was calculated from basically whatever grades I had on file from Pearson. Whatever grade I saw in Pearson, that was like 90% of your grade. And the other 10% was if I saw anything as far as Alex was concerned, I essentially gave you credit for it on some level. But Alex is like 10% of our grade. Yeah. So I'm going to go like this. And let's go like this. I think everybody But yeah, no major announcements. Let me just take some time to get through what we need to get through today. And with whatever time we have remaining, I'll open the floor for like any specific homework questions. You can ask questions on anything from like Pearson, like current homework, old exams. You can even ask questions from Alex, right? Okay. Or as long as you're just kind of present until we let class go. Like even if you're working on something else, I mean, I really wouldn't know. And it's not a big deal. Just as long as you're taking advantage of this time and you're able to do what you need to do. Let me reboot this because usually that's what I have to do. And oof, this looks right. Okay. So what we're going to be doing today, we're going to move into chapter 2. Yes. To access these slides, if you go to Blackboard, there's going to be a section. I think it's at the very bottom, like folder number 7. It's going to say box. That's where all of all the stuff you see me writing. I load a PDF there. Before we part ways, I usually load a PDF, so you can pull it there. This feels like it's working okay. Go like this. Hey Google, turn the fan on. Hey Google, change your volume to 70%. I don't know if she heard me or not. Okay. So we're going to start chapter 2 with section 2.1 quadratic functions. Also be aware that these sessions are streamed live on YouTube. Let me see. Let me go like this. Go like this. Okay, let's try this again. It's looking good. So we're moving into chapter 2, polynomial and rational functions. Polynomials and rational functions. So with section 2.1, we're going to work on this notion of what do we mean by quadratic functions. And so some objectives here are we want to see how to graph a quadratic function in standard form, graph any quadratic function, and then to solve problems modeled by quadratic functions, right? So we said we have that a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, where the leading coefficient is not equal to 0, this is called a quadratic function, right? So the leading coefficient is not 0, we call this a quadratic function. It says the quadratic function f of x equals a times x minus h squared plus k, again, where that leading coefficient is not 0. This is said to be in standard form. The graph of f is a parabola where the vertex is going to be h comma k. Hey Google, turn the fan off. I felt like I was screaming over the fan. So the graph of this function is a parabola where the vertex is going to be h comma k, and the parabola is symmetrical with respect to the line x equals h. It's called the axis of symmetry, or the axis of the parabola, right? If the leading coefficient is positive, that means the parabola opens upward. If the leading coefficient is negative, that means the parabola opens downward. Right? Okay, let's see if we can see some of this in action. So here we're asked to find the standard form of a quadratic function whose graph is this vertex and passes through this point. Okay. So let me see. I have another version here of the same question, just with some more space. I usually like to use graph paper. Okay. And let's go view. What the? Okay. We need to reset democracy. Sorry. Let's go to view seamless. Okay. All right. So it says find the standard form of the quadratic function whose graph has this vertex and passes through this point. So if you have a formula sheet, it is a good idea to probably load this formula to your formula sheet. You don't have to commit this in memory. You just want to have it readily accessible, right? So the standard form, let's write it out. Standard form of a quadratic function. Okay. I'm going to move this over here. Like that is fine. So the standard form of a quadratic is going to be f of x equals a times x minus h squared plus k. All right. So we're given, it says the vertex is negative 3, 4. So that's our h comma k is going to be negative 3 comma 4. And it says passes through the point. So if that's a point on our parabola, that can be our x comma y. Can be negative 4 comma 7. All right. So we want to plug these components in. Again, this is going to be our h. This is going to be our k. It's going to be our x. This is going to be our y. So we're going to plug those components into the above formula. So we don't know what a is, right? We're going to plug in x, which is going to be a negative 4. Notice I use a blank set of I use a blank set of parentheses to substitute the x first. Then I plug the number in for x, right? That helps us to keep track of the negatives. So x minus our h, what's our h in this case, is -3 squared. Our k is 4. I'm not going to use parentheses here, but that's going to be 4. And that should equal our y, which is 7. Okay. So this is actually a good time to mention order of operations, right? Just to do as a quick refresher or recap, right? And now feel free to like type in the chat or respond in the chat or just engage in the chat or unmute yourself. But so order of operation is what PEMDAS LR, right? So PEMDAS, please excuse my dear Aunt Sally's last request. A lot of people don't use the LR. I'll explain what the LR means momentarily. Okay. So the P typically stands for, not typically, the P stands for parentheses. Okay, so we were gonna, again, this is order of operations. So it's the order in which we do things. If we don't do the order properly, we'll get the wrong answer, right? So the P stands for parentheses. The E stands for exponents. Riddle me this. This is one of the questions. Which do we do first? So the M stands for multiplication, and the D stands for division. Which do we do first, multiplication or division? So hopefully your spidey sense is going off. It's kind of a bait question. Okay. So it's kind of a trick question. It just depends, right? So this is where the LR comes into place. We typically group the multiplication and division. So whenever we have to decide between multiplication and division, we just do that left to right. I say that to say sometimes we actually do divide before we multiply. Um, so again, whenever we have to decide between multiplication and division, we just do it left to right. Okay. And then same thing. So the A stands for addition, the S stands for subtraction, and it's the same thing. We group addition and subtraction together, and whenever we have to decide between addition and subtraction, we just do it left to right. And again, the L stands for left, and the R stands for right. So let's PEMDAS LR. Please excuse my dear Aunt Sally's last request. Okay. So whenever we go to simplify or work examples, we target our parentheses first. Let me kind of do like this. Let me move this out of the way. Give me just a moment. This doesn't have to be so big. Okay, that looks good there. And then I guess we can kind of keep working with you. About here. All right. So now using order of operations, but first we ask ourselves, are there any parentheses to simplify? So we would start here. Just like in life, this is similar to life where idealistically we want to transform ourselves from the inside to the out, right? If we work our way from the outside to the in, which is what most people do, makeup or doing things that are surface, getting surgery and stuff like that, versus okay, let me change my diet, let me eat cleaner, let me get rid of the junk food, stop all the fast food, let me eat fruits and veggies and water, so I can clear up my skin instead of putting makeup on, or you know, let me let things go and not have it. Let me not be so egotistical and create all this havoc. Let me let things go, because a lot of times that stress, it causes your skin to break out. It just don't it makes you unhealthy. It makes you sick. It kills you. But when you learn how to like let things go, then things are better. I'm just kind of launching into that, using this as a platform. But again, that's kind of how I use. That's my personal philosophy. I try to fix the innermost machinations of myself first, and try to get it to a level where it will shine through. Um, so same thing here, right? We're going to start with the innermost set first, right? So if we're targeting this part that I'm circling, you should see like, okay, if you look at this, there's nothing inside this parenthesis to simplify, but we have a double negative going on here, right? So let's address that double negative. Okay. So some of my students will do the following. Right. They'll draw a vertical bar to line up their equal sign. I think it's fantastic. Right. Let's go to partial, something like that. And like that is what I need. Put this back. You can put that like there. Doesn't really matter. That's fine. Okay. So if we start with a double negative, this guy here, style is blue. That's going to become what? +3. And then everything else just stays the same and come down. So the -4 essentially just comes down. Squared comes down. The 8 comes down. Notice again, at this stage, we have everything. Only thing we don't know is A, so we can actually solve for A. One equation, one unknown, we can solve. Every time we have an unknown, we need an equation. But we only have one unknown here, and we have one equation, so we can solve. Then if we say the -4 plus 3, what is that going to give us? -1. So -4 plus 3 adds to -1, and then I'm going to bring everything else down. Okay. So then -1 squared is going to be a +1 times A is just going to be A. Everything else comes down. Subtract 4 on both sides. A equals, what is that? 3. Right? So we got a leading coefficient was 3, so that we're saying that our A is 3, and our H comma K was given to us. That was -3, 4. Okay. So let's plug this into our equation. You got the sneezes. She's hilarious. Okay. We're gonna use f of x. I'm just pulling this from the top. A times x minus h squared plus k. We're gonna plug in what we just found, right? So we're gonna say f of x. The a was 3. X. The h is, what's our h? Our h is -3. Notice my use of parentheses. And then it's going to be +4. We got one more thing we need to do. So then our f of x is going to be 3 times x plus 3 squared plus 4. Right? So our claim is that this is the equation of a parabola with the above vertex, and it should pass through the desired point. Okay. So then I'm going to share something with you. I'm going to show something. So say we get this answer and we wanted to check it. Like say this was a testing environment and we wanted to see, well, how can we check this answer, right? Hopefully that's not too small. Okay. Say we want to check this. So what I'm going to do, I want to show you. Uh-oh, I don't know if I can give this person credit. They are mega ultra late today. Who is this coming late in my class? I'm gonna let him in. I mark him as late. I won't mark him as absent. Yeah, usually after the 15-minute mark, I mark people as absent, even if you attend. Let me do this, but let's see. This is this one. I'm gonna do this. Okay, come on, like this. And we need to show this back. I think that'll be good. Let me just check. It should be fine. So now, let's check this, right? So we said the vertex was -3, 4, and it passes through the point -4, 7. So I just want to check and see if this actually works. So I'm going to open up my graphing calculator. Give me just a moment to pull it up. Yeah, this one. Let me just reload and refresh. All right. And it's right here. All right. So let's check this in a graphic calculator. Now, some other software that we can use. Oh, I got to do that? Probably. I forget it is backed up. I just wanted to mention some other. Come on, I need you to kick over. Why are you not kicking over? Let me do this. That looks better. Okay. Some other software that we can use. So I'm using an emulator to do this, but some software that you guys can use. One I recommend is called GeoGebra. GeoGebra. This is for like graphing, like doing digital graphs. I'm gonna say geogebra.com. It's free software. I think it's free. Um, but yeah, it's for like, so where I'm using my graphing calculator, you can go to GeoGebra and kind of do a little bit of research, and they'll explain how to graph in there using their program. It does. I think it does like 3D graphs, 2D graphs, all this kind of stuff. Trig, sine graphs, all that stuff. Okay. So say I wanted to check and see if this actually works, right? So the vertex was -3, 4, and passes to the point -4. I'm watching the clock. -4, 7. So I'm gonna go here on the calculator. Thank you. Stop. I'm getting some yummies. Okay. Um. So I want to plot these points, right? So on the calculator, I'm gonna go here to stat. I'm gonna click there. Oh, I'm gonna click on stat. I'm gonna go to number 1 for edit, and I'm gonna type in these order pairs. So we have what? Uh, -3 and -4, and then the corresponding y values of 4 and 7, right? So the vertex, yeah, okay. So then in the upper left hand corner here at stat plot, I'm going to turn my stat plot on. So I'm going to hit second y equals, and I want to turn this on. Is somebody in the waiting room? No, I think we're okay. So I'm going to turn the stat plot on. So then when we hit graph, you can see the points that we just. So then we want to see if our function passes through these points. So I'm going to go to my y equals, and I'm going to do this 3 times x plus 3 squared plus 4. Okay. So now when we hit graph, notice the vertex passes through the point -3, 4, and it also passes through the point -4, 7, right? So we got the desired result that we wanted to have. GeoGebra, we can also do this in GeoGebra as well, geogebra.com. There are others. The students had one that begins with a D, but I can never remember the name of it. And there are others. I think like Wolfram Math or something. It's a lot of different free software, but this is the one. This is another one that I use is GeoGebra to generate digital graphs, just to kind of visualize things and see how it all comes together. Okay, let me see. So I think with my earlier class, that was the last one that I did for today. So then a student had asked the questions from the homework, but I wanted to kind of give this group. Oh, Desmos. Yep, that's right. Desmos is definitely the other one. I wanted to give this group a chance. Did anybody have any specific questions? If there aren't specific questions, what I'm going to do is pull the question that the student had from earlier, right? And let me kind of update this. Oh, well, this is fine because I didn't put a time, right? So let me go ahead and include the one that the student asked from earlier. I thought it was a good question. So he had already started section 2.1 homework, and he asked me to kind of go through this question. Let me crop. So this was his, but if you work it, you'll have a similar question with different numbers. Hang on. I'm going to go like this, like this. Bring it out. All right, and center it. Okay. So this came from the homework for section 2.1, and I just thought it was a good question, and it actually kind of matched the time. So I don't want to keep you for no more than about 10 more minutes. That's about how long this question takes. It says for the equation we have y equals. So let me see. It's what? A B C D. It's 5 parts. I feel like it's a bit much. Let me just try and see if it works. Copy. That's 2, 3, 4, 5. Okay. So for this first one, this, come on, stop. Crop. And I just want, come on, maybe right here, I just want this. All right, well, I'm just gonna try to isolate each section, right? Okay. So we see the result, but let me kind of call on it. So the original we have is what? Y equals -2 minus 6x minus x squared, right? The part A says, does this parabola open upward or downward, right? So what I would do, first I would put it in descending power order, right? Right now it's not in descending power order, so I want to put the highest exponent first. So this -x squared, then the next is going to be minus 6x minus 2. So in this form, now it should be clear that the leading coefficient is negative. So that means the parabola opens downward because the leading coefficient is negative. All right, so that was part A. So then let's go like this. Here. I don't want to show the answer just yet. Let me copy. Let me crop. I want to work with this. And let me paste. And let me crop. Let me crop to B. Yeah, I don't want to show the answer. Okay. Okay. So again, part B asks us to find the vertex, right? There are several techniques that actually work here for finding a vertex. The one I did with the early group was the Vertex Formula. So just to be a little different, if you want to see the Vertex Formula, you have to go to my YouTube channel and watch the presentation from the earlier class. It's going to have a similar title to you all's from today, but watch the one from an earlier class. With you all, instead of doing the Vertex Formula, I'm going to do a demo on completing a square, right? So we're going to do a demo on completing a square. Also, let me make this statement. So for this class, it is expected that everyone's comfortable with factoring, right? The typical college algebra student is not comfortable with factoring. My intent is to kind of finish out section 2.1, and then with extra time throughout the week, we can take some of that time to review some of these factoring techniques. I actually scanned a whole chapter that's devoted to factoring, and it's actually loaded in our Blackboard page. If you go to that box, that folder number 7 in box, open up that link. There's going to be a folder number 5 that says handouts. It's in there, and there's a whole chapter devoted to factoring. It'll explain all the different scenarios that would typically come across in college algebra on factoring. So we can take some time to kind of review that, especially, I think I mentioned it before and I forgot about it. And so we can actually do that going forward. Yeah, I just need to remember. That's the main thing. So instead of the vertex form, so if anyone needs help with factoring, I would say reference a handout. Also, search YouTube on, for instance, this one I'm going to do completing the square. So this is going to be a demo on completing. I think there's an E in there. Hey Google, spell completing.
Confirm is spelled C-O-N.
Nope. Nope. Hey Google, spell completing. She can't hear me. Hey Siri, spell completing.
Completing. C-O-N.
So yeah, I got it right. Okay. Completing, right? I felt like I wanted to put that silent E there, but anyway. But anyway, this is completing. This is going to be a demo on completing the square. All right, so let's do this demo. Let's start with the original. Y equals -2 minus 6x minus x squared. So the first thing, honestly, with the way this is written, I will put this in descending power order, right? put it in descending power order first. So then we should get y equals negative x squared minus 6x minus 2, right? So now the main thing with completing the square, the first thing is that we got to get that leading coefficient to be a 1. Right now our leading coefficient is a negative 1, right? So we're going to do completing the square on one side of the equation. I may have done examples where we're manipulating both sides. In this demo, we're going to manipulate one side, right? So what I'm going to do, I am going to factor out a negative 1 from the first two terms, right? So this is going to be y equals, now we can factor out a negative 1. We're going to be left with x squared plus 6x. I'm going to leave some space. And then the minus 2 just kind of stays on the end. Completing the square step comes in the form of, we're going to say plus b over 2 squared. We're going to say plus and minus. Right? We're really just adding 0, but we're using this thing of this plus and minus b over 2 squared, right? So we're going to say plus b over 2 squared and minus b over 2 squared. So that's going to be plus 6 over 2 squared, and we're going to say minus 6 over 2 squared, okay? This is the completing the square step, okay? So let's simplify these numbers. So then we're going to have y equals, this negative stays here. This x squared comes down, the 6x comes down. 6 divided by 2 is 3. I don't want to keep you more, about 5 minutes, give or take. 6 divided by 2 is 3. 3 squared is 9. So really what we're doing, we're saying plus 9 minus 9. Okay. I'm going to bring everything else down. Okay. So now I want to pass that second 9. I want to get it out of the parentheses. So I need to multiply it by a negative. So then we're going to have y equals negative. We're going to have x squared plus 6x plus 9. And then if we distribute that negative into that second 9, that also becomes a plus 9 on the outside of the parentheses. It's going to be a plus 9 here, again, because of the negative. And then the minus 2 just goes with it now. Okay? Let me add some space. Again, this is just a demo on completing the square. Okay? So now in this form, here, let's go ahead and do one more. We're going to have y equals negative x squared plus 6x plus 9. And then the second one is 9 minus 2. It ends up being a 7, right? So now we should be able to factor this trinomial inside the parentheses, right? And it should factor into the following. 3, right? So x plus 3. Squared, right? Plus 7. So then that's going to be the, what is this? Completing the square. What are we trying to answer? Oh, the vertex, right? So before my earlier class, my other class, we used the vertex formula, which in my opinion is much easier, but I still wanted to do a demo on completing the square because we need to get practice with that. So then from here, our vertex being our h comma k ends up being negative 3 comma 7. All right, that's the vertex. Okay, I see the clock. About to let everybody go in a few minutes. So let's see, part C. Negative 3, 7. Axis of symmetry. So then part C asks for the axis of symmetry. The axis of symmetry is always just going to be, for a parabola, is going to be the x coordinate of the vertex. So the axis of symmetry is just going to be x equals negative 3. Okay. Style like this. ABCD. Dx for the x-intercepts. Did x just for the x-intercept? Yeah. So then for part D, what's the time? I'll keep us for about 3 more minutes. The x-intercepts. So for the x-intercepts, let's just, what we do is to find the x-intercepts, we set y equal to 0. We set y equal to 0, right? So, okay, I'm going to use yours a little bit different. I'm going to use that completing the square step, right? So if we set y equal to 0 at the part that you see at the top of the screen, we're going to have negative times x plus 3 squared plus 7. We're going to set that equal to 0 and solve. So what I want to do is isolate my squared term. So if I subtract 7 on both sides and divide by a negative, I'll get x plus 3 squared equals a positive 7. I subtracted the 7 and I divided both sides by a negative, right? So at this point, we can take the square root on both sides. If we take the square root on both sides, we get x plus 3 is going to be plus or minus the square root of 7. Right? Whenever we do a square root or an even root, we have to introduce plus or minus. And then if we subtract 3, I know. Yeah, the fasting thing. So I follow this guy on YouTube. His name is Infinite Waters Ralph Smart. He's a practicing psychic. Like, I mean, he seems like he's had accurate things, and like a lot of people are warning about like this impending food shortage. Like they're gonna intentionally. It's like it seems to be this ploy to just kind of wreak havoc and take charge. But basically, so I just got a notification. He was like, "You're gonna have to start learning how to fast and like grow your own food." So just kind of, kind of be ready for that kind of stuff. I'm just throwing that out there. But if we go ahead and finish this out, x equals -3. And honestly, like especially if you had to build or do any kind of calculations, this kind of stuff actually does pop up. So that it is becoming a matter of life and death. And just rhythms and just kind of being precise and like measurements and precision. That's what mathematics is all about. So we get this -3 plus or minus 7. So with you all, I did it a little bit different than I did for other class. If you want to see a different presentation, just watch the video from my earlier classes. We got the same result, but we did them different ways. So then you pick whichever one resonates with you most. I'm not going to graph because I don't want to keep you much longer. That was part D. But yeah, earlier we did several of these in a different way. Okay. So I'm actually going to stop the presentation here. Anybody, if you have any questions for me, feel free to type it into the chat or go ahead and ask it or whatever. Otherwise, if you don't have any burning questions, enjoy the rest of your day. I'll see everyone tomorrow starting at 5:15. All right, guys. Thank you for being awesome. Deuces up, 8 down. Walk around. See you next time.